Hello students, in this video we'll consider a separable ODE which arises in the study of the Brostisius and Todochrome problem. Let's consider dx dy is the square root of c over y minus 1, where here c is a constant. We can notice that this is a separable differential equation, but I want to analyze it more carefully than that. What I'd like to do is I'd like to write dx over dy as, by simplifying the square root, as c minus y over y. And then we're going to make a substitution. So in its separable form, this is dx is equal to the square root of c minus y over y dy. And now here comes our substitution that will keep the equation separable. What I'm going to do is I'm going to let's do it like this. Let's let y be c sine squared of an angle phi, okay? If that's so, then if we make this substitution, what happens? Then this will turn my separable differential equation into dx is equal to the square root of c minus c sine squared phi over c sine squared phi. And then what is the differential? What's dy turn into? dy is going to turn into 2c sine of phi cosine of phi d phi. Great. Now we can see over here that the numerator is going to simplify to cosine squared. So what's going to happen over here is there's no c's, it's homogeneous in c. So what I'm going to have over here is this is going to turn into a cosine of phi over sine of phi times 2c, and then sine phi cosine phi d phi. Now the signs are going to cancel out, and you have 2c. You have a 2c cosine squared phi. So let's integrate that now. So x is going to be what? X is going to be an antiderivative of 2c and then cosine squared of phi d phi. Of course, we can already use the power reduction formula to write this as c integral of what? Of 1 plus the cosine of 2 phi by power reduction d phi. And now one sort of final twist to this is I'm going to let theta, to make my formula at the end of the day look nice, I'm going to let theta be equal to 2 phi. And then this integral will turn into what? So let's make that a little bit more clear. Let's do it like this. That's our substitution. So we're going to make a substitution over here. That theta is going to be 2 phi. If that's the case, then what does our integral turn into? It turns into c integral of what? 1 plus the cosine of theta. And then d phi is what? d phi is theta over 2, d theta over 2. And now we can integrate this and figure out that x is going to be what? So x, therefore, will be what? Will be c over 2. And then the antiderivative of 1 is just going to give me a theta. And then the antiderivative of cosine is negative sine. So I have a negative sine of theta. And that's my x. Now we can figure out what y is. Well, let's recall what we made the substitution over here. So my y is really c what? Now, sine squared by power reduction is 1 minus cosine of 2 phi over 2. And so now once we have 1 minus cosine of 2 phi over 2, that's the same as we're calling that 2 phi is equal to theta. This is going to be theta over here. So our parameterization for y is my y is going to be c over 2. And then 1 minus the cosine of theta, 1 minus cosine of theta. And now we can observe that this is the equation of a cycloid, right? So this is the parameterization. So the solution of this ODE, so this curve is a cycloid. And the circle that's being rotated over here of a circle rolling with radius c over 2. Now when we solve the Todochrome problem and the Brostisius problem, we'll see that both equations have this as a differential equation that results from the dynamics, and we'll be able to apply this ODE now that we know that the solution to this ODE is the cycloid. Thank you very much.